Hello and welcome to Epiphany. In this video, we'll be going over how to use Epiphany to solve the type of problems you typically see in an Algebra 1 class, including a variety of different types of problems and how to use the various features that Epiphany has. If you're looking for information on how to register, how to set up your account, how to create your first assignment, please go to our other videos on getting started and they'll have information on how to do that. Let me start off by sharing my screen. And we've already logged in and are sharing an assignment that's been created for Algebra 1. This is a handful of problems that we're going to use to go through some of the different options for entering problems and getting feedback from Epiphany. For now, most of the problems that you're going to use in Epiphany will be in the form of an equation. Even if you're trying to solve something that is where the instructions are to expand or to simplify or to plug in, all of those will be handled in the form of an equation with Epiphany for now. We will have some other options coming up later on. There are some limitations to what we can handle. We don't handle word problems or graphical problems like geometry problems, problems that require interpreting a picture. We have that planned for the future, but those will be a ways out. I do want to mention that Epiphany is designed to handle any math constructs. So there will be things you can put into the system that will confuse us, that we won't understand. And it's designed to tell you, hey, I didn't get that when that happens, but we'll talk about that as well along the way, as well as some of the limitations that exist. So assuming you've already registered and logged in, let's go ahead and start working on this first problem. This is a typical linear equation, and we're going to go ahead and solve this step by step. One of the things about Epiphany is it's designed to make you go through step by step in the problem. As these problems get harder, hey, many of you were very, very good at solving math problems in your head. In elementary school, in middle school, that was a good thing, right? As you get into more advanced math, you don't want to try and solve it all in one step. Some of these problems take a half page or even a page of work. You want to go one step at a time. So we're going to start off here and we're going to put everything on one side, and the x is on the left and the numbers on the right, and I get 2x equals 8. Oops, I went a little too fast here. I made a mistake. Let's see. It's asking me some questions about this, what I did. I did the same thing to both sides. I did minus x plus 1. I simplified the left and right sides, and I'm going to save this. And it's going to tell me, hey, try those one step. Oh, I see what I did. I meant to subtract 1 from the right side. I added 1 instead. So I've shown one way that you can enter information into Epiphany. You can just type, and some of these are pretty straightforward. You can type them out. For more complex functions, there is a GUI to enter things like square roots, exponents. Some of these work the way you would expect them to. And then there are other more complex functions like radicals, calculus expressions, other types of things that might not come up as often. We're not going to worry about those for now. Most of those won't come up in algebra problems. And then there's also a handwriting recognition system that allows you to enter steps just using handwriting. We're not going to go through that now either. We're going to hold off on that. So I'm going to fix that step. You'll notice that I added a comment here with those notes that I put in. Your teacher or your tutor might be able to share some comments back to you. We're going to come back here and enter our next step. And we'll finish this up by typing x equals 5, and I'll click done to indicate that we are done with this problem. And I'm going to turn off my debug messages for the rest of this video because we don't need those. Okay, let's go on to the next problem here. So this is a quadratic equation. The first thing we're going to do in solving the quadratic equation, we're going to put all the variables and expressions on the left side, set them equal to 0 in order to solve them. I'm going to start out with x squared minus 5x plus 4 equals 0. And I can factor that and get x minus 4, x minus 1 equals 0. And now I can, okay, I want to enter two solutions here. And there are several ways we have to enter two solutions. First of all, if I enter one of them, it might say, hey, we'll look for some other solutions. If I enter too many, it might say, oh, some of those aren't quite right, and check again. There are some situations where that it should come up in the process of solving a math problem. Not very much in Algebra 1, so we won't talk about that much here. I've shown you one way to enter multiple solutions, just the word or. You can type that in. You can also say x equals 1. Oops. X equals 1. And here I'm going to go to these answer options, and I'm going to add a solution. It's just going to put the word or there. 1 or 4. That's a way to enter two solutions. Or I could enter x equals, and I could use braces 1 comma 4 to indicate the set of 1 comma 4. It's not equal to the set, it's equal to one of those two numbers, but that's another way you can express it here. And I'm going to go to one more thing. There's another way we could solve this, and that's with the quadratic equation. The quadratic equation allows us to enter this as a fraction. X equals, b is 5, so negative b is 5, plus or minus. So how do I enter the plus or minus symbol? Well, that's here on the GUI. I can, let's close that up. I can open this GUI up, and here is under algebra, my plus or minus symbol. You'll notice there's also a, on the rollover, there's a little expression that's the text shortcut for how you can enter that manually. I'll show you those more later, and we're going to make them bigger so you can see them. 5 plus or minus square root of 5 squared minus 4 times 1 times 4 over, oh, wait a minute. I wanted the whole thing to be over 2a. I don't want just the last part to be over 2a. Well, first, I can just backspace, and it will delete that divided by sign when I backspace, so I don't have to worry about that. And then I can use shift and an arrow to select what part I want to be in the numerator, then hit the divided by sign, and it will do the right thing. And so here I've got x equal to this expression. It's going to check that. That's still correct. And I can say x equals, I'll make the fraction first this time, 5. I'm going to use the keyboard shortcut. Backslash PM is plus or minus. Backslash SQRT is square root. That's the square root of 9 over 2. And I get x equals 5 plus 3 over 2, or 5 minus 3 over 2 is 1 or 4. We're back to the solutions that we had above. So that's how you can enter multiple solutions and work through quadratic equations with this. And we'll cover a couple of other things a little later here. We also have a video for any teachers who might be watching this. For math purists, there are some things you've noticed here probably that are not completely kosher when it comes to mathematics. I talk about that in a separate video for teachers. Right, let's call this done, and we'll move on to the next problem. Oh, by the way, let's go back to that. When you're done with the problem, it shows all of the steps that you took, including the mistakes. And that's what you want. You want your teacher or your tutor to be able to see where you made mistakes. That lets them help you. The objective is to work through them yourself and then figure out where you're making mistakes so you can improve on them later. So, don't hesitate to let your teacher see all the warts and bumps that you went through to get to the right answer. That's what we're trying to do. That's the process we're trying to work on. And let's go on to the next problem. It's a FOIL problem. It might be a problem where a teacher asks you to multiply and combine the terms for x plus 3 times x minus 2. Since we have to have an equation, we're going to set another variable, y, equal to that expression, and we're going to use that to simplify it. Same thing would work for factoring or simplifying or expanding other types of expressions as well. So my first step, I'm going to say y equals, I'm going to do this a little differently and say x times x minus 2 plus 3 times x minus 2, and hit enter. Well, first of all, I want to point out you want to use parentheses. If I didn't use parentheses here, it would be wrong anyway. But wait a minute, what did I do wrong here? I didn't do anything wrong. There's one thing that I want to point out, and that is if there's a variable immediately before parentheses where it is an implied multiplication, that confuses us. So you want to use explicit multiplication in those cases. Basically, it looks like a function to us, and we're working on how to resolve the difference between a function and an implied multiplication. But for now, put the multiplication symbol in there and it'll work. If you think you're right and you don't want to work through, hey, what happened here, you can always go here to answer options and continue anyway. And either, hey, I think this was correct, I want to keep going, or say that you're not sure and you want to continue. Find a continue anyway. It's just a way of keeping going if there's something that we got confused about. So I'm going to use this button right here. This is for copying. It'll copy that text, and I can paste it down here. And then also Control C and Control V work, as well as Control Z for undo. I'm going to do Control V here. It's going to paste that same thing. Oops, I don't want two of them. Control Z will remove that. Also, Control Y works sometimes. We're working on fixing it so it works all the time. I'm going to put a multiplication symbol in right here. And let's go on to the next step. Now this should work just fine. And we'll go ahead and continue to simplify this. Y equals x squared minus 2x plus 3x minus 6. And finish it up, y equals x. I'm using the caret symbol for squared. You can also do this with the GUI, but it's all the symbols and shortcuts that you're used to make this work. Plus x minus 6. And at this point, we'd say we're done because we have combined and expanded that expression. Okay, for this next problem, we're going to work on an absolute value problem. And I'm going to start this out and just say, okay, 2x minus 3 equals 5. Oops, I only got one of the solutions. It's going to point that out to me. I'll have to try that again. I'm not going to worry about that for now. I know what I did. 2x minus 3 equals, again, we have that plus or minus symbol right here on the GUI under functions, the algebra functions plus or minus. This equals plus or minus 5. And I can continue like that. Or I can also enter this with the shortcut 2x minus 3 equals 5 or negative 5. Or with the, for my next step, I can say 2x equals 3 and then backslash PM space to lock it in. 3 plus or minus 5. Actually, I can actually type plus or minus anything other than a letter at this point is going to complete that text, that text shortcut. So I have 3 plus or minus 5. Let's enter and continue with the next step. I can also click the button for next step, but enter or clicking next step will get me to the next step. And I can also do this with this handwriting tool. And if I got to check something, sometimes I have to resize it. It's designed to be used for like tablets and mobile devices. And sometimes, it's too big right now. I'm going to resize this. I'm going to reload this. Reload. And now it will be the right size. And I'm going to say for my next step, x equals 3/2 plus or minus 5/2. And enter. And we can do problems that way too. It's really nice for mobile or tablet devices. If you've got a stylus, it's a way that you can work on these without having a full keyboard handy for you. It also works with other types of mathematical expressions, including exponents and square root symbols and things like that. And I can finish this up by saying that x equals 1 or 4. Those are my two answers, 3/2 plus 5/2 or 3/2 minus 5/2. And I'm going to click done to indicate that we're done here. I do want to mention that nested absolute value problems work. What happened? Oh, first of all, it's not correct. It should be -1 or 4. There we go. Not sure what I did there. I might have typed something. Maybe I didn't put a space in there. Nested absolute value problems work. However, we can get confused sometimes which absolute value symbols go together. So just watch for that. I recommend making pairs of absolute value symbols at the same time. Like make the first one and the last one, and then make the ones inside separately if you're going to use nested absolute value problems. And then I also wanted to mention that we don't support multiple intervals. So if this was an inequality, we don't have a way of entering the solution to the absolute value of 2x minus 3 is less than or greater than 5 yet. We're working on that and hope to have that available soon. Okay. Here we have an inequality. These work exactly the same way. I'm going to start off by adding 3 to both sides, and I get negative 2x is greater than 8. And I'll make the mistake a lot of students make and divide by negative 2, and I say x is greater than negative 4. Oops. I made a mistake there. You got to reverse the symbol when you do that. I do want to point something out here. If I type x equals negative 4, this causes a problem for us. You'll notice we say, hey, there's an error. There's something that went wrong in our code with this, and we're working on this. We make a note of these whenever they happen and refer them to our development team to fix them. If you see this, we've taken great made attempts to make sure that anytime there's an error inside of what we do or something confuses us, because we can see any type of math that could come in, we're going to handle that and give a soft landing like this. It says something looks wrong here. We can't figure out what you did. And then you can either fix what you did or find a way to continue anyway if you think that was right. In this case, I shouldn't have, x equals negative 4 isn't right, and I know what we're doing inside our software. We're fixing that to make that work. You can also always report a problem here, but a lot of these are automatically captured if we show an error here or certain other error pages that might come up if something happens. I should have said that x is less than negative 4, and I'm going to say that we're done at this point. That's done. So on to the next problem. Sometimes you might be given instructions to plug in or substitute. For example, if I want to find y when x equals 5, I can say y equals 3 times 5 squared plus 2. If I type that, well, that's not right. And we have an error here that shows up again. These two expressions aren't equal to each other. What I want to do is I want to plug in. So I'm going to say I'm going to plug in or substitute x equals 5. And now, let's try this again. And now it understands. I was trying to replace x with 5 rather than say that these two expressions were equal to each other. And I can finish this up. Y equals 3 times 25 plus 2. And y equals 77, and we're done. Okay, for our next problem, we're going to have simplify a radical expression. And in this case, what we're looking to do is split this up into different pieces. So I'm going to say y equals square root of 12 times square root of x cubed. I'm doing this with keyboard shortcuts because I've used them a lot, but you can also use the GUI. The square root symbols here, exponents can be here. This is just a caret symbol to give you exponents, and this is backslash SQRT for that. Actually, they show up here as rollovers, backslash SQRT, and caret with the exponent after it. Let's close that and close these. Okay, continuing, we're going to split square root of 12 and the square root of x cubed up into two different pieces. Y equals square root of 4. And notice that I hit the right arrow to come out of the radical. If I type times 3 here, it's inside the radical. If I hit the right arrow, then times square root of 3, that's a separate one, times square root of x squared, times square root of x. So far, so good. Now I can say y equals 2 square root of 3 times x times square root of x. It's going to mark this correct, but I want to mention something here. A small handful of your classes might require that the square root of x squared is indicated as the absolute value of x. We have to be able to handle all different sorts of classes, all different sorts of standards. We try to be a little relaxed on that. Eventually, we'll have switches to handle that. But for now, you can enter it the other way. In fact, I'm going to copy and paste this and just place the x in an absolute value symbol. And this is also going to be marked as correct. Eventually, we'll have options for how strict the expressions are and checking the form of the final answer and whether it's fully simplified. Some of those checks aren't in place yet, but for now, it's a good way to check your work along the way and see how you're doing with things. And for the last problem I want to show, this is a property of exponents problem. We're going to start, we've set another variable equal to the expression because we want to simplify it. We need an equation. And forgive me for a moment here. I'm going to grab something from another page. Here's our first step. I'm going to copy and paste this time. Just moving these pieces around, multiplication is commutative, so we can put each of these pieces together, put the A's together, the numbers together, the B's together. And I've used multiplication symbols in between each of these to make sure everything worked just fine. Turns out I didn't need them here. Now I want to put the various variables together. So I'm going to say z equals 12, a to the 5 minus, oh, wait a minute. That minus sign popped out of the exponent. And you'll notice that Desmos does this too. It's a shortcut designed to be helpful. Usually when you put a plus or a minus in an exponent or a subscript, it works for subscripts as well, or an equal sign, you don't want it to be in the exponent. And anyone who's used these systems for long enough has put a lengthy solution in an exponent, and that's not where you want it. So it automatically pops out of that. If you really do want a subtraction in the exponent, type the second piece first, then go back in between them and put the minus sign in there. And you can get that to work. And I'm going to say times b to the 2. I'll type the 3 next and then go back and put the minus sign in there. And we'll continue from there. And now I can say z equals 12, a to the 3rd times b to the negative 1. And this problem says I should use only positive exponents, which means I have to make the negative exponent a fraction. That's z equals 12a cubed over b. And I showed you before, if it didn't select the entire numerator, how you can use shift select to select the part that you want, or you can put that in parentheses. That also works as a way of selecting the numerator of a fraction. And that covers it for the types of problems you typically see. Here's another problem. I'm not going to go through this, but it's just a problem to convert a point slope form line into slope intercept form. We don't do checks at the end of the problems to confirm the correct form or ask what the correct form would be for this problem, but we plan to add that in the future. For now, it's a way to work through the problems and check your work step by step as you're working on them. Oh, there's something I forgot to show. I'm going to go back to that. Over here, let's say I was looking at this problem and I wanted to look at this again and save it for future review, this problem for the radical problem. I can go up here and say, I want to add tags to this. And I can type in review. I have to click on this to select it. And then you should hit save to make sure it saves. And it'll save that. If you don't, it might not save it, or it might lose it when you leave the page. I can also type my own flag, Kevin, check. And I can make my own tags. I can look at those specific tags later if I do a filter on all of my problems. So you can use this as a way of remembering which problems you want to review with your tutor or which ones you want to review for the test or the final exam later on. Couple more things I wanted to cover before we wrap up here. When you're done, let's go back to the assignment. You can print out this assignment, and it's going to include all your steps, including the mistakes that you made. It is in backwards order here. I'm going to work on that. But again, the goal is, hey, your teacher should be able to see where you made mistakes. That way they know this is something that you did yourself. It's not something that the system did for you. There's also some information for them here about what we're doing that we're not doing the work for you. We're just helping you with helping you catch your own mistakes along the way. And then there's also a link if you want to invite them to be able to see your problems in Epiphany and directly comment on them. They can make comments on your problems as well. This link is a way for them to see those problems and request access if you want to give them that access. And then you can save this or print it out, your choice. I'm going to close this now and I'm going to print it. You can also run reports on your own problems. Search on which problems you wanted to look at date range, name, whether they have mistakes or not, various tags in the problems, if you want to look at specific problems and review them later. Um, and then there's also some additional videos that go into some of the limitations on what Epiphany can handle and some workarounds for those. I'm not going to go into all of those for now. Most of those apply to more advanced mathematics that we're still working on. Um, Thank you for listening to how we can use Epiphany to solve Algebra 1 problems. And we look forward to seeing you on the site.